Now that we have all the fixtures defined, we can actually go ahead and take a look at the simulation on this. Because what we've defined in here with our setup is CamWorks is already taking care of the rotation for us. So if we simply come up to the top and we just select Simulate Toolpath, you can see that we have different settings here, but you'll also notice the fixture shows up in our toolpaths now. And it does that because once you define a fixture in assembly machining, it'll now take into account any of these collision options, and you can set it so if it hits, it stops. I'm going to leave it open because I do want to show you that it does highlight if there is a collision as well. So we'll go ahead and we'll just run it through here. We'll speed it up just a little bit. We'll show stock, which again, this is one of my favorite things. And then you can also go to next setup. So when I hit OK, it'll run through, stop at the end of this setup, and then I will have to select play before it goes to the next one. And if I hit play, you'll see it rotates, then it rotates again, and then it rotates for the last setup. You can see here that there's hitting because the tool's too short. So if we turn on the collision or pause on collision, then it would show actually where it's going to hit. And you can see that you get feedback here, as well as being able to see it on the display. You get feedback that there's actually a hit there. So if you leave that on, obviously it'll keep showing it. If we just hit this, it'll go through and finish, but you can see this is a pretty big set of interference. If we had a small amount where just the tool was barely hitting or the holder was just nicking the chuck, it'll show it as well. So it's really good from a feedback standpoint, but the nice thing about the fixturing is it actually shows it in simulation, and then it gives us the ability to see how it's going to interact from the CamWorks standpoint. Now from here, just like we would do in previous modules, we would obviously have to go through and make tool changes to this part. So you would open it up, maybe change your tool, because you can see the overall length's 2.5 inches. It's not really long enough for this part. If I hover out here on the screen, you can see we probably need like a 4-inch tool. So we could swap this out for in the tool crib for a tool that's longer. You do have the ability, however, to come in here and say, let's say we're going to have that as a 4-inch tool now with 2 flutes. And then if I go over to the holder, you can see that it's sticking through the holder, so I can change my protrusion length. Let's say we're going to make that 3-inch. If I look out here, looks like it's going to clear. And when I hit OK, CamWorks is going to ask, do I want to change it or do I want to add? Generally, what I would recommend is you would want to add, because then that creates a brand new tool with that holder for that scenario versus changing your default tool, because you may use that tool in several other instances and you don't want to update it and remove it and then not have a short tool. So if we hit add, it'll automatically add rebuild, and then you can see that now I have a tool that's station 26, whereas the tool above it, the previous one, was tool 1. So this is where you can get into, let's say we want these two tools to be the same. So we can right click, combine, and then we can say, well, I want to use mill tool 22 as my standard parameter, which has tool number 26 in it. So I hit OK. And now both of those are tied together in the same operation. And if I rotate that around, now I have 2 tools that are using that length. Now if I were to come up here, let's say we go to this rough, and we have that rough, and I want all of those combined because I want to run them together. So we can say combine operations, and we'll hit OK. But you can see that it's still using tool number 1, so we want to change that now to be tool number 26. So we'll open this up. We'll go to the tool crib, and that one we just created is right here. And you can see it's set there, it's long enough. So we'll hit select. Yes, we want to replace the holder. Hit OK. And now if we were to simulate this tool path, you can see it rotates the right orientation for us. because we're machining Z down. And now we no longer have those collisions. So it's an easy way to use interference detection. You use the simulation in the assembly mode to verify everything is going to work the way it is, but then it's really easy to modify a tool or add a tool to make sure your programming works the way it's supposed to. And that covers it for basic 4-axis pre-positioning in assembly mode. Thank you.